Greetings, Earthlings. Well, you'll notice that the logic analyzer is turned off and it's been unhooked. And what does that mean? Well, that means I found the problem that we saw in the last video that was keeping this thing from working. And so now it actually appears to be functional. So what was the problem? It wasn't too hard to find, actually. The thing I noticed is, looking at the code, well, I'm looking at the logic analyzer output. The thing I noticed was that the bits, we had a bit, let's see, it was on this instruction here. And what we were seeing was we saw an 03, 0100, and an 000100. Okay, the thing I noticed was that, so that's actually, it turns out to be bits, what bit was it? Bit 3, I think, of the word was a 0 when it should have been a 1. Or bit 2 was a 1 when it should have been a 0. So the thing I noticed was that every other instruction that it ran, those bits were the same. Intentionally, it's supposed to be the same. This is the only one where they were intended to be different, and they were the same. So that led me to think, well, maybe they're shorted together somehow. So first thing I did is I took a blank board, because when you buy the boards, you get 5 of them, so I have spares. Got a blank board and checked those 2 lines to make sure it wasn't a board layout issue, and it wasn't. So then what was the next most likely thing? Well, I have this little connector here, as you can see. And I put that there to make testing easier, although I haven't found a connector that connects to it yet. Those are 50 thousandths spacing on those pins. So a standard header does not plug in to that, obviously. So they're close together, and so it's quite likely that there could be a solder bridge. And when I took a look, indeed there was. So I fixed that, and we can see now, if I turn the power on, we reset and start it up, and we'll see it blinking Morse code. Okay, there we go. There's a close-up of the LEDs, and you can see it. Let's see. Dash dot dash 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 dot 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 dash 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 dot dash 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 dot 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 dash dot dash. There you go. So now moving onward, well, I guess I can test all of RAM. I'm just using a single location in the memory, and I'm only using the monitor memory right now. When the machine resets, it maps the ROMs and the monitor RAM into the low address space, well, into the address space of the machine, the 32K word address space. The regular RAM, there's 32K words here, is mapped out. Then this processor has a 64K mode. It boots in 32K mode. It can go to 64K mode, at which point these will be mapped into the high memory location, and the regular RAM will be mapped into the low 32K. So I've got to test that stuff too. Meanwhile, I'm still working on, well, there's an I/O board, and then there's a monitor board, drive a CRT monitor, graphics display. And those are in progress. But I don't know what the lead time is right now for PC boards from China. Again, these were made by JLC PCB. It was where I got these from. They're in China, and I don't know what the turnaround will be if I were to order, you know, I/O boards or display boards today because of this whole coronavirus thing. But anyway, work continues.